In this lesson, I am going to give you two coordinates, and you are going to need to come up with an equation of the line in all three forms. So, you have three equations to choose from. You have point-slope, you have slope-intercept, and you have standard form. In order to do point-slope, you need to know a point and a slope. Well, I know 2 points, but I don't know any slope. In order to do, so that was this one. Okay, so in order to do point slope, I need to know one coordinate, which I have at least one, but I also need to know the slope. In order to do y equals mx plus b, I need to know the slope, and I need to know the y-intercept. Okay, well, I don't have the y-intercept. Actually, I do have the y-intercept, but you probably would not recognize that right off the bat. So I'm not going to teach you that way because most of you won't remember to do it that way. Okay? So we're going to start out using, and also you have standard form, but with standard form, there's nothing to plug into it. You always convert to standard form, but you can't, there's nothing to plug in to just get to standard form directly. Okay? So we're going to start with point slope form. The problem on this particular one is that we do not know the slope. Okay, so I need to first of all figure out the slope. So I will call this x1 and this y1 and this x2 and this y2. And I need to find my slope by doing y2 minus y1 over x2 minus x1. Okay, so I will do that. And when I do that, I will have 4 minus 0 over 0 minus 6. 4 minus 0 is 4. 0 minus 6 is negative 6. When I reduce that, I get negative 2/3. So my m is negative 2/3. Okay, now I know that I labeled this first coordinate here as x1, y1. From this point on, it doesn't really matter. You can actually, obviously, you have to, for m, plug in negative 2/3. But for your x1 and your y1, you could plug in either coordinate. You could plug in the 0.60, or you could plug in the 0.04. It doesn't matter. Pick either one. Since I have mine labeled as x1 and y1, I'll just stick with that. So I have y minus 0 is my y1 equals m, which I already wrote, as x minus my x1, which is 6. Okay, so this is already actually the formula in point slope. Okay, I really and truly don't need this 0 on here, so if you wrote it, that's fine. If not, that's fine too. I will distribute this now. Negative 2/3 times x is negative 2/3 x. Negative 2/3 times negative 6 is positive 12/3. 6 times 2 is 12, because remember this is really 6 over 1. So I have positive 12 over 3, which becomes positive 4. Okay, here is your equation in slope-intercept. I just noticed up here I forgot my e, sorry. All right, and then we need to convert this to standard form. And so to convert this into standard form, I will add 2/3 x. And I will have 2/3 x plus y equals 4. And remember that in standard form, you can't have fractions or decimals, so I need to get rid of that 3 that's in the denominator. So I will multiply everything by 3. So 3 times 2/3 becomes 2x. 3 times y becomes 3y. And 3 times 4, becomes 12. And this is what it would look like in standard form. All right, again, I gave you two coordinates. When I've given you two coordinates, you've got one, so this is x1, y1, this is x2, y2. Okay? No matter what formula you use, you are going to need to know your slope. So the first thing I will do is I will find my slope. So just a reminder that your slope is y2 minus y1 over x2 minus x1. So your y2 is 3, your y1 is 3, your x2 is negative 1, and your x1 is 2. So I have 0 over negative 3, which is 0. Hint, hint, hint. Red flag to you. When your slope is 0, it is a special kind of a line. Okay, slope of 0 has a line that goes like this, and it's a horizontal line. And horizontal lines always, 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 every single time have the equation y equals. It's the y that is being held constant every time. The x can change, but the y is held constant. And the question becomes, what's the y held constant at? Hint, hint, hint. Y is 3 here, and y is 3 here. So the only equation you need to write for this whole thing is y equals 3. And that equation is actually in point slope, it's in slope-intercept, and it's in standard form. So those are special cases with horizontal and vertical lines. Okay? Here's another one. Again, you would want to try and plug something into this equation right here. Or you could try to plug it into here. Okay, if I knew the y-intercept and I knew the m, I could plug it into that. I don't know the y-intercept, so this is not going to be helpful. This formula will be helpful if I know my m. So I will find my m first by taking y2 minus y1 over x2 minus x1. Okay, so negative 3 minus 4 over negative 1 minus negative 1. Of course, this becomes boom, boom. And I have negative 7 over 0. And you can't divide by 0. So when you have a 0 in the denominator, that means you have a slope that's undefined. Okay? So I want you to remember this. When your slope is undefined, these are some things that happen. Okay? The thing that automatically happens is you know you have a vertical line. And I want you to think about what variable is held constant in this case. On a vertical line, it's your x variable that is held constant. Your y value can change because you can move up and down that line, so your y can change, but your x is held constant, and your x is held constant at, hint, 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 negative 1. So this would be the equation for that line. Again, that is in point slope, slope intercept, and standard form.